Hello, this is Robert Casey, and this is an announcement of the availability of the new Haplogroup R YSNP prediction tool. This will replace the old YSNP prediction tool that introduced about around 10 years ago, and this uses two variables for much higher accuracy. This is the replacement of my original L21 SNP predictor tool that was introduced in 2012. This new one covers 63% of all YSNP branches under RL21. So the scope of this and the coverage of this is much wider than it was previously. It also expanded to cover a total of 100 haplogroups, 73 across RL21, and another 27 across other parts of haplogroup R. The average accuracy is now exceeding 99% for all these branches being included, and also this is a big increase from the 90 to 95% accuracy of the previous models. It handles both input from YSDR reports from family tree DNA, as well as from spreadsheets where you parse the multi-copy markers and that kind of stuff. I will continue to add new haplogroups as time allows. This now uses two variables for the binary logistic model, and this is no longer an empirical model. This is actually made from a statistical model using a program called AccuStat. It uses AccuStat to calculate the constants, but the formula is the same for all these prediction models. Only the three constants of the model change for each prediction. It uses both YSDR signature match and genetic distance from the signature, which acts as a big filter. And there's no testing requirements anymore for YSNPs because the genetic distance acts as a big filter and it's no longer required. Genetic distance eliminates convergence issues between various haplogroups that are predictable. The input screen for the YSDR values still does not change very much, so there's a little change in that area. And below is the actual link to go to the new predictor tool. Once you hit submit, or when you hit verify, it will produce all the YSDR values. So you can sanity check and make sure that the multi-copy markers hadn't messed up things. Multi-copy markers need to be removed that have extra values. Otherwise, those particular testers cannot be run through the tool. So you check for values of 30s and 40s for CDY markers, and in the low 20s for 413. And if they're not in the lower 20s for those as well, then you probably have extra values in your YSDR markers. Only around 1% of the people will have these extra markers, but you need to know how to handle them when they occur. So if you have extra copies for 19, 385, 459, 464, YCA22, CDY 395S1 and 413, they can all have extra copies of the markers. So you must reduce 19 back to one marker. Most of them reduces back to two markers, and 464 must be reduced to four markers. Just reducing the amount by removing extra copies of the higher values, that will work, but it won't give you the highest accuracy. So for the normalizing the markers, if they have extra values, you shouldn't just remove the highest ones. That will get them through, but a lot of times it won't predict properly. They tend to be cloned in pairs, being a recombination. And so you really need to follow the consistency of how genetic rules, because these are basically cloned in pairs. So you got, if the count is the same, well, first of all, you got to remove the values with the highest counts first. So if you have one marker value that's repeated 5 times, you take one out of it, and then you look at them all again. And if the same one again, you take out another marker value. And you keep on doing that until they're all the same. And then you start on the high, low, and middle, taking out at the next level until you're down to the desired amount. Now this only affects 1% of the testers, so it doesn't have to be done that often. So here's actual output from the screen. And if you notice in the top, the second column, the first one is 100%, and the second one is 10.9272%. Now this is not considered to be a real issue, because anything over 50% is considered positive, anything below 50% is considered negative. That's just the general rules. And so you will see, fairly high values that overlap, but you shouldn't be too concerned about them. But that does show you that it could have a very remote chance of testing positive for the other one as well. There are several options for the output screens. If you click on any of the headers for the columns, it'll sort that column by that particular output. Also, there's on the bottom of the screen, if you want more rows to be shown, you can do them, or you can display them all. If you see two haplogroups with large numbers, these are probably less accurate due to some kind of conversion going on. The signature max is the second most important column, because that's really what drives the prediction the most. And this third most important is the high genetic distance, because that acts as a good filter. If you have a pretty high signature max but the genetic distance is high, it's not going to work. And then last, there are links to analysis. Those will go to primarily SAP charts, but also some other charts as well. There's also a little bit required in interpretation of these results. Any value that shows 50% or higher is considered positive. Any value that's under 50% is considered negative. This is a normal practice for binary logistic regression models. However, anything that hits in the 50 to 75% range could occasionally be negative, because these are boundary condition testers, as well as those that are predicted negative between 25 and 50%. One or two of those may be positive sometimes. These are rare occasions, and these exceptions only occur about 1% of the time. There are assumptions, and I always need to make people aware of what those are. CDY markers just mutate too fast for charting and for YSNP prediction in the time frame they were using, so they are ignored as input. Also, the frame rate today shows 389-2, which includes the same mutations in 389-1. So that double counts the same mutation, and so you should use a delta format if possible, or it'll automatically calculate for you. If you do use an Excel spreadsheet and you do use the delta format, you need to hit the little radio button that says delta, so you get the correct results that you're wanting. There are some exceptions for ones where YSNP prediction does not work. And you have recombinational loss of heterogeneity or relox. These are in the palindrome regions where they recombine and result in one mutation that changes 5 or 6 marker values. Also, if you have massive nulls, they will rarely be predicted accurately as well. These are not normal mutations, and they result in multiple changes just for one mutations, so the mathematical models can only handle one type of genetic biological type of mutations. The relock mutation show up with matching pairs in 459 and 464. And massive nulls are where there's a lot of marker values that have 0 values reporting. There again, this is less than 1% of the testers, but if you notice that you have a lot of matching marker values in 459 and 64 and a lot of zeros, YSNP prediction is not going to be very highly accurate in those particular exceptions. There will be continual updates planned in the near future. A few new predictable haplogroups will be added over time, but most of these are going to be pretty small scopes, since I hopefully we've gotten most of the large ones by now. There are a few older haplogroups that will be updated as well. These are ones I did quite some time ago, and they're quite dated. So, both the techniques have been slightly tweaked over time, and also there's been a lot more data to be entered as well. Non-L21 predictable haplogroups just aren't as plentiful as they are under RL21. It's just the nature of the way that the genetic isolation is worked out. Also, any kind of paid reviews that I plan on announcing will be added to prediction tools as well. What are the advantages of YSNP prediction? It takes the guesswork who belongs to a predictable haplogroup and who doesn't. Just the inclusion of a few false positives will reduce the accuracy of your charting, and that's your ultimate goal. It helps with creating valid testers and reveals those who should not be included in your analysis. YSNP prediction is just a high accuracy methodology for collecting valid data. The ultimate goal here is not to predict, but is to take all the data that is predicted to be the same haplogroup and to chart them to see how everybody's related. I'm also announcing an analysis service to basically do this work for you, to update the ones that have done, and to do ones for the smaller ones which haven't done yet. Data collection is very time consuming and requires significant skills to accomplish. Also, analysis requires technical skills and time to conduct such analysis. Testing is not inexpensive of what you need, but proprietary tools just don't provide too much help. Income from these services will be used to recover costs for updating the software predictor tool, and I need to update my software for automating the data collection, and also potentially costs for labor for data collection. These services will only be available for Haplogroup R, since my database is currently limited to Haplogroup R. Here is a summary of the cost for these services. The labor to conduct such analysis is really primarily based on the size of the project involved. So the three baselines are, there's a base fee for a small one, which is 10 to 25 branches, a medium one, which is 26 to 50, and a large one is 50 to 100. And there's only 6 that are currently known, with over 100 to be custom. Then you also have charting options. If you don't want any charting, there's no extra charge. If you want one pass, that's 20%. If you want 2 passes where I fine-tune things, which does improve the accuracy somewhat, then you add 40% instead of 20%. Also, data collection is a major issue, as well as any kind of documentation of the analysis. So for a manual data collection of only confirmed testers, there's no charge when it's minimal collection. And I would do, if it's an existing one, I would do a minimal amount of work no matter what. If you want a moderate amount of extraction, it's 20%. If you want extensive, you got to add 40% to the original cost. Same way on predicted testers. Once you get a model built, then you get a prediction, and you can go data mine for other testers within other projects. There again, if it's only minimal, it's no charge. Moderate, 20, add 20%, and extensive, add 40%. Then, depending on what kind of documentation you want, that can also ask. If you don't want any documentation, then there's no charge. If you want a 4 or 5 page executive summary, add 20%. If you want a 20-screen YouTube video that explains all the analysis in great detail, then you'd have 50%, because that's pretty intensive to do a presentation. So here are the costs associated with BY 9001, a predictable haplogroup. The base fee is 34 branches, and that puts it in the $150 range. I did a 1 chart on passing, so that's an extra $30. Data collection for confirmed testers was moderate, so 30. And data collection for the predicted was minimal, and documentation was a 4-page summary, which is an extra $30. So the total service would be $240 normally, but since it's already been done previously, fairly recently, about a year ago, then you get a discount of $90, so your discounted price would only be $150. So these are pretty reasonable services prices. I mean, the discount, it's $150. This includes 102 testers, and it probably would add another 10 and 20% of either new testers or upgrades to the existing testers. This offering is usually less than the two most common YDNA testing options, which is ordering a 111, which is $219, or upgrading to Big Y700, which is $229. So this is well under analyzing all 100 testers versus just yours and comparing your result with 100 other testers. So there are some terms with this offering. First of all data used in this analysis will be available to the customer and can be updated and modified by any person ordering these offerings, and so you have full rights to all the data and do anything that you want to with it. But I can only include data from public YFTNA reports can be used for analysis. If the customer wants to, he can go add private data as long as he complies with the Family True privacy rules. Analysis should be posted. Any analysis that I do will also be posted and updated for all other consumers to see. There will be no analysis just for a private individual only. Any usage of this data must also include reference to the original source, which is myself. So if you're interested in this analysis, please send an email to me with what you have in mind, and then we can get together on a phone call and discuss yours in depth. Only predictable haplogroups we consider it. You just can't do certain clusters. It rarely works. Certain clusters only work 5 or 10% of the time. So it's just too high of a risk that we can't do it with a high accuracy that I require. Only the haplogroup are haplogroups, but no private data can be used. Discounts, even if the haplogroup has already been analyzed, and there has been 100 haplogroups currently analyzed, if you want to see how SNP prediction works, you should, or how to determine which SNP predictable, which of your YSNPs may be predictable, which may not be. You should see the video in the back of this presentation on determining your predictable haplogroup. And also special requests will be considered. I've created several presentations on YouTube where you can get up to speed on how this technology works. First of all, the first one is how do you determine a predictable haplogroup? And it goes through the criteria that's required and what it takes to be a predictable haplogroup. Then once you've determined that you have determined a predictable haplogroup, then you want to start tracking your data in an Excel spreadsheet. You need an analysis format. You really can't do it in a word processing file, and you can't do it with existing YTNA tools. And then if you're interested, if it's not too big of a project, you should create a haplogroup project, because that will generate interest and get more people on board with testing, and it's just a good idea. So this presentation shows you that how to collect data and also to create your own haplogroup project. And then there's a presentation of what a YSTR signature is. And so if you're not familiar with YSTR signatures, this is a good summary. And then there's another presentation on how YSNP prediction works. This is all the different flavors of YSNP prediction at different levels, and also goes in quite depth of the binary logic regression models that I use. Then if you want to do this yourself for YSNP prediction, you can watch the YSNP prediction using AccuStack. AccuStack is available for $10 for a download, and it's a pretty easy product to use. I also have done a presentation on charting and how it works, which is just another form of YSNP prediction below the predictable haplogroup. And I give a step-by-step of how I use SAP for charting. And then you need to understand that statistics are not always your friend, genetic genealogy. And this shows you in depth of some of the weaknesses statistically of genetic genealogy distributions. Like, for instance, everybody assumes these are all normal curves, but all the statistical measurement for normality of curves is pretty marginal and sometimes outright rejected. Also, privacy is a big issue. It reduces accessibility. I'm a big fan of accessibility because if we currently have about half the data being private, that means people got to test twice as much. That's extra, $50 to $100 million worth of cost that doesn't need to be, required. Also, I have written a white paper on how binary logistic regression works for YSDRs. And also, if you're interested in TMRCAs, I've created a pretty unique TMRC estimates, but this only works with the 10 largest predictable haplogroups because it requires a very large amount of data. And if you really see what can be done in the distant future, if you're not part of one of these 10 larger haplogroups, I have about a 100-page chart that charts over 1,067 marker tests, which includes around 450 big Y testers as well.